In today's lesson, we're going to learn about simplifying rational expressions. And keep in mind that the rational expressions is just another way of saying that we're simplifying fractions or reducing fractions. So at points in this lesson, you may want to pause it and copy out some of these notes into your own personal notes. What I'm reminding you of here when we see that the 63 over 45 reduces to 7/5, what we've actually done to reduce that, the work is shown there. We realize that 9 goes into both evenly. So if we divide 63 by 9 and 45 by 9, we're left with 7/5. So what's happening is the 9s are actually canceling out. We often just haven't shown that in our work. So what you can see here, similarly, up here, that the x plus 5 and the x plus 5 cancel out. And that's how you're left with x minus 1 plus 3. Now when we get to x minus 1 over x plus 3, what this states here in the words is that you can't reduce any further. And you can't reduce any further because there's adding and subtracting that prevents you from doing so. So it's really important that you realize that, because in the past, many students have made the mistake by trying to cancel out their x's. So let's look at an example here to fully understand what it is I've just spoken of. In this example here, our binomials of x plus 5 and x plus 5 are exactly the same, so they can cancel out. What we're left with is x minus 7 in the numerator and x plus 3 in the denominator. And that question there is done, except for you might realize it says simplify and state the restrictions. What the restrictions want us to always list is all of the cases where the denominator might equal 0. And we can't have 0 in the denominator because that's undefined. 0 can't go into any number. So we need to be sure that we state here that x cannot be equal to -5 or -3. Because if I substituted either of those into the denominator, they would equal 0, and anything multiplied by 0 is 0. Try to always state your restrictions in chronological order as well, from least to greatest. Here we have a different example. It's similar, but the only thing is it's not factored yet. So because there's addition and subtraction separating all of our terms, we can't cancel out. So the first thing that I'm going to do with the numerator is I'm going to factor, and that's a nice easy trinomial because a is equal to 1. So my magic numbers are +4 and -3. Those two factors multiplied together equal -12. And they also add to be +1. On the bottom, I am left with x plus 5 and x minus 3. So that's why it's so important that we really mastered that factoring on the first couple days. That question now we can cancel out, but before we cancel out, I'm going to state my restrictions at this step, just to be sure that I don't miss any. So here I realize that x cannot be equal to -5, because that would make the first binomial equal to 0. It also can't be equal to +3. Either of those would make a denominator of 0. So now that I've stated my restrictions, I can cancel out to have a final answer of x plus 4 over x plus 5. There it is there. All right, let's do a few examples here together. I'll do example C for you, and then I'll also leave you with a few examples to take home. X plus 7, I'm going to factor the top, so my factors are going to be +7 and -6. On the bottom, my factors are going to be -6 and -1. -6 times -1 gives me +6. And those two added together is -7. This is a good spot to do your restrictions so you don't miss any. I realize that x cannot be equal to +1 or +6. Now that the restrictions are done, I can cancel out the two binomials that are the same, and I'm left with a final answer of x plus 7 over x minus 1. So for question D, I look at the top and I realize I still have addition separating my terms, so I'm going to need to factor that as well. And I realize that I can common factor out 5 from both terms and also 2 x's. So once I've done that, I'm left with x squared plus 4. And it's all going to be over my trinomial there, which I can common factor first as well. So I'm going to be left with x squared plus 6x plus 8. So my denominator can still be factored further. So I'm going to do that right here. So I'm just going to rewrite my numerator. Now the magic numbers that work on the bottom, we still leave that x out there, that doesn't disappear, is going to be x plus 4, x plus 2. Now at a glance, it appears that you can cancel out your x plus 4, those binomials, but they're not identical because of that exponent. So I'm just going to highlight that for you so you can see the difference. My x squared is not the same as just x, so these two binomials could not cancel out. So the only thing that can cancel out is our x squared and our x. So I have 2 x's here and 1 here. Those can cancel out. Otherwise, everything else remains the same. So here I'll put up our answer. So we have 5 with 1x, x squared plus 4, all over x plus 4, x plus 2. And then I'll state my restrictions now as well. X cannot be equal to -4, -2, or 0. So that concludes this lesson. What I'm going to leave you with here is these 2 examples. I want to be sure that you read through them, think through them, and answer them. We'll discuss them as a class tomorrow. As well, you're left with the last 2 up here. So tomorrow I'll be looking for those 4 things completed at the beginning of class.